Okay, in this video we are gonna work with larger, I'm gonna say larger non-square numbers, right? And we're going to work on how do we take the square root of these things, right? And so taking the square root of something that's a bigger number, all right? And so, but I'm not going to get into huger numbers because it's all kind of the same philosophy here, right? So let's start with something like when you talk about let's start with one that we'll see a lot, which is the square root of 50, right? So when you have the square root of 50, right? Again, in the first video we talked about you want to try and split 50 up into two factors that are going to have one of them be a square number, right? And so you got to think about what your square numbers are. So my square numbers, right, are 1, 4, 9, 16, 25, 36, 49, and I'm almost done. We'll just go down the line until we get to 10, right? 64 is 8 squared, 81 is 9 squared, and 100 is 10 squared, right? So 50, I think about the factors of 50. 50 has, a few different factors. It's got 1 and 50. It's got 2 and 25. It's got 5 and 10, and then that's it, right? And the only one of those that has one of these numbers on the list, and it has 25, is this one right here. So we're going to rewrite this as the square root of 25. I always put the square number first, times the square root of 2. Because I can simplify this. And when I simplify the square root of 25, that gives me 5, right? And now I'm just doing the positive roots for these videos, right? So if you're like, where's the plus and minus sign, right? Well, that's more in the quadratic formula application. We're just looking at how do we simplify these things. So you would get 5 times the square root of 2, okay? And that's where you're at. Okay, so let's go a little bigger. Let's do square root of 68. Now, think about this, all right? And I know 68 is going to be divisible by 4. Okay, so I'm gonna start with 4 and see where that gets me. So I'm gonna go, what is 68 divided by 4, right? When I do that, well, 1, right? 4 goes in, and you get 28, and you get 17. So this gives me the square root of 4 times the square root of 17, which means that the square root of 4 simplifies to 2 times the square root of 17. There's really not much else I can do, okay? And so let's do another one. What if we do 72? Right? Now, I'm gonna show you two things here. Now, what I see with a lot of people is a lot of people aren't very strong with their factors when you start looking for square numbers that are kind of up in this area. Like beyond 25, most people can't multiply like multiples of 36 or 49 or 64 with any kind of regular success in their head, right? And now if they have a calculator, they can figure it out. But these are things we're going after, stuff we know for sure. Well, one thing I know for sure, all right, and I know this partly because of the last problem, but also partly because I understand how numbers work, is I know that 72, I know that I can take 4 out of 72, right? I know 72, 4 goes into 72. So I'm going to divide 72 by 4, right? I'm going to get 1. 1 times 4 is 4, and you get 32, and I get 18, okay? So this is what I'm going to do. I'm going to go square root of 4 times the square root of 18. Okay, and I'm going to say, great, I know the square root of 4 is 2, and we have 2 times the square root of 18. And then before you ask yourself if you're done, you have to say, well, is 18 in simplest form, or can I pull another square number out of that? Well, your factors of 18, you would just kind of continue along this line. Your factors of 18 are 1 and 18. Well, that's a big no. And then you have 2 and 9. And then, wait a minute, 9 comes out, right? So you have 2 times square root of 18. So let's rewrite this as 2 times the square root of 9 times the square root of 2, right? And so that's what I have there. And square root of 9 is 3. So you have 2 times 3 times the square root of 2. So all you got to do is just multiply these two front numbers, right? 2 times 3 is 6, and 6 times square root of 2. Now, had you understood, and if you were better with numbers, you would have realized that 36 actually goes into 72 two times, right? 72 is equal to 2 times 36. And had you figured that out, or had I figured that out right away, I could have done 36 times the square root of 2 and gotten to this immediately, right? But I wanted to show you this because I wanted you to see that you can still get there, right? You can still get there. It just takes a little more work. And, you know, a little more work isn't always a terrible thing, okay? So let's do a couple more. All right, so let's do the square root of 99, right? So 99 is divisible by, I know 3 is going to go into 99. So I know 3 goes in 33 times, right? So I'm going to try that. I'm going to see if that does anything for me. Well, 3 is, you know, a prime number, but square root of 3 I can't really do anything with. Square root of 33, I can't do anything with either. There's no factors of that are square numbers. However, I can, let's just see if we can bust that up. So I know I can write that as this, right? Square root of 3 times the square root of 11. So 3 times 11 is 33. So let's rewrite this, right? Square root of 3 times the square root of 3 times the square root of 11. Well, here's the thing. When you're multiplying two square roots that are the same, so if I have the square root of 3 times the square root of 3, right, that's the same thing as the square root of 3 squared. And when you square a square root, you just get what's under the number, right? So you get 3. And if that doesn't make sense to you, just multiply the rational expression out. Just go square root of 3 times square root of 3 is basically put them under the same radical. Then you have the square root of 9, because 3 times 3 is 9. And you should know that the square root of 9 is 3, right? And so you can get there. But this is great, because whenever you have two things under a radical that are exactly the same, you know that you can take the square root of those. You can combine pairs of those and get that number pulled out. And so for this one, that means that I'm going to have this turn into 3 times the square root of 11. Now, again, had I factored this, quote unquote, properly, 99, right? Had I factored this properly, I would have factored it as the square root of 9 times the square root of 11. And that would have gotten me to this right away. But again, just want you to see that there's more than one way to get somewhere. All right, let's do square root of 120. Okay, we're almost done. I'm just going to do a couple more. All right, square root of 120. So let's, I don't even know where to start with this one. So let's just, let's pick the square root of 40 times the square root of 3, right? So I know 3 is prime, so I can't do anything with that. But 40 is definitely not prime. And the first two things that pop out in my head when I think of 40, I think, ooh, 4 and 10, right? Here's the square root of 4 times the square root of 10, and there's 3, right? So I can do the square root of 4, right? The square root of 4 is 2. And then I also know that 10 is, that's not something I can take a square root of, and I can't pull any factors out that are going to do that. So I can't leave it like this, though. That's a no-no. You can't do that, right? So what you have to do, right, is you have to say, okay, square root of 4 is 2. And then 10 times 3. So you multiply those together. You multiply it like this, 10 times 3, and then that's going to give you 2 times the square root of 30. All right, so hope this helps, guys. Good luck.